If you want to think clearly about an interstellar visitor crossing our solar system, start with humility. We like to believe we have the cosmos neatly cataloged. Asteroids here, comets there, bare rock or rock coated in ice that boils away under sunlight to make a halo and a tail. But any object wandering for millions of years through the frozen dark between stars will accumulate ice. A cloud of gas tells you only what lies on the surface, not what hides beneath. You wouldn't judge a book by the dust on its cover. You shouldn't judge a traveler by the vapor on its skin. 3I Atlas, our newest visitor from the void, is forcing that reminder upon us. Its spectra are dominated not by water vapor, but by carbon dioxide, an abundance 8 times greater than what we see in typical comets. Its tail glows with nickel emission but no iron, a pairing that should be impossible. It carries traces of cyanide, and the light it scatters shows a polarization that breaks every familiar rule. Each clue, taken alone, raises an eyebrow. Taken together, they whisper that maybe the problem isn't the sky, it's our categories. The most dangerous move in science is to decide in advance what nature is allowed to be. If we insist that every body with a coma must be an ordinary comet, we risk repeating the oldest mistake of all, confusing our models with reality. When Galileo lifted his crude telescope to Jupiter and saw moons circling another world, the establishment didn't build a better lens. They built a cage of dogma around his observation. It took the church 350 years to admit he was right. The moral isn't theological, it's methodological. Don't guard your beliefs, test them. Build the instrument, take the data, and let nature speak, even if she whispers something inconvenient. We resist that because it threatens a quiet addiction, our need to be at the center. Galileo's critics clung to a universe that revolved around human importance. Our modern institutions cling to something subtler, the idea that we've already reached the summit of understanding. Both impulses are the same reflex, dressed in different clothes. But the truth is, astronomy has already pushed us off the pedestal. We've found thousands of Earth-Sun analogs, other houses on the cosmic street. We spend billions sniffing their atmospheres for the faint breath of microbes, and that's worthwhile. But if there's even one intelligent resident out there, a civilization older than ours, their footprints might be easier to spot than their germs. Imagine a tennis ball tossed into our backyard, a probe, a fragment, a discarded artifact. Imagine a construction project glinting in the dark, a ship whose cooling vents mimic a comet's breath. Such signs could be easier to detect than microbial methane hundreds of light years away. If the discovery of intelligence would alter our future more profoundly than the detection of algae in a distant sea, then our curiosity should reflect that. We repeat that extraordinary claims require extraordinary evidence. True enough. But extraordinary evidence usually requires extraordinary funding and the courage to look where mockery points its flashlight away. Even our flashlights are dim. A century ago, we didn't know that infrared light existed. Our eyes evolved to read sunlight reflected off predators and prey. They see what mattered to survival, not what exists. Had we evolved under a cool red dwarf, our world would glow in infrared, and blue light would be exotic. If our star had burned hotter, our eyes might register X-rays instead of color. The universe didn't change when we discovered those wavelengths, only our instruments did. That should make us cautious about declaring what isn't there. Most of the universe is invisible to us. Most of its matter is dark. Most of its energy, darker still. We haven't yet unified quantum mechanics with gravity, the 2 pillars of physics, on a single sheet of paper. So it's not mysticism to imagine technologies that exploit domains we can barely describe. A propulsion system that interacts with dark matter would leave no trail in our telescopes. A ship that exchanges momentum through quantum fields might pass through our solar system unseen, save for a shimmer of gases we misread as cometary. The absence of evidence in the bands we monitor is not evidence of absence. It's a warning that we may be listening on the wrong channel. And detectability cuts both ways. Even catastrophic events can be silent across the void. A global nuclear war on a nearby planet would be apocalyptic for its inhabitants, but invisible to us. The energy released would be lost to the cosmic background within moments. Our own civilization has been leaking radio signals for just a century, a bubble of noise barely 100 light years wide, a whisper inside a galaxy 100,000 light years across. If the universe is a dark forest, we have already cracked a twig. Maybe someone heard. Prudence in how we shout and humility in what we expect to hear back aren't paranoia. They're just physics with manners. The thread connecting all of this from Atlas's carbon-heavy chemistry to its nickel without iron fingerprint and its rebellious polarization curve runs through our culture of science as much as through its equations. The pioneers of quantum mechanics sat on hard benches, scrawling symbols that violated intuition. Superposition, uncertainty, entanglement. If social media had existed in 1925, it would have mocked them. Nature didn't. She rewarded their open minds with a theory that powers our lasers, our computers, our MRI scanners. We can honor that tradition without abandoning skepticism. Openness isn't credulity. Skepticism isn't dismissal. The right posture is disciplined curiosity. Follow the anomaly wherever it leads. Design tests that might prove you wrong, and never use sarcasm as a shield for fear. So what do the current anomalies really mean? A coma tells us about the surface, not the soul. Unfamiliar chemistry hints at origins we don't yet understand. Strange polarization tells us the dust and ice are built differently than our textbooks suggest. None of this demands a technological explanation. All of it forbids complacency. The cosmos keeps reminding us that our sample size is small. 3 interstellar visitors in 1 decade, each breaking a different rule. Perhaps coincidence? Perhaps a hint that the void between stars is more complex than the tidy model of our childhood. Where does that leave us? With work to do. Build better instruments, eyes that see beyond the narrow slice of light we call visible. Fund the audacious as well as the careful. Archive and share raw data so that truth isn't a matter of authority but of replication. And most of all, treat we don't know yet, not as an embarrassment but as an invitation. When the next interstellar wanderer drifts in wearing a cloak of carbon dioxide and an accent of unfamiliar light, resist the twin temptations of premature hype and premature dismissal. We are not at the center of the universe. We are not even at the center of understanding. But somewhere between those two truths lies the frontier that defines us. The universe is large enough to surprise us. The only unforgivable sin in a cosmos like that is refusing to be surprised.